PR.10 Geometry. Area formulas for rectangles, triangles, and trapezoids. Southwestern College, Professor Maria Olivas. PR.10 Geometry. Area formulas for rectangles, triangles, and trapezoids. This is a prerequisite topic for definite integrals. Our objectives are to determine areas of rectangles, triangles, and trapezoids using formulas from geometry. 1. Areas of rectangles, triangles, and trapezoids. Recall the geometry formulas for area. I'm going to go ahead and draw a chart here. The chart is going to have 3 columns and it's going to have 4 rows. Across the top of the 3 columns, I am going to write down at the top of the first column, I'm going to write name of shape. At the top of the second column, I'm going to write picture of shape. Or another thing I could have written here could have been the figure. And for the third column, I'm going to write down formula. And this column is going to represent the formula for the area of the shape. Going back to the first column, I'm going to go down to the next row, down the second row. I'm going to write down the word rectangle. Next to rectangle, to the right, underneath where it says picture of shape, I'm going to draw a rectangle. The 2 shorter sides I'm going to label with a W, and the 2 longer sides are going to be labeled with an L. The formula for the area of a rectangle is going to be the area is equal to the length times width. Before I write down that formula, I'm going to erase the word formula at the top, and I'm going to write down area formula, just because I don't want there to be any confusion that these formulas are related to area. Now writing down the formula, it's going to be A equals L times W. Now going back to the first column, in the third row, I'm going to write down the word triangle. Then under the second column for picture of shape, right next to triangle, directly to the right of the word triangle, I'm going to draw a triangle. I'm going to draw a dashed line segment coming from the very top of the triangle that's going to come down to the base, perpendicular to the base. I'm going to label that as H for the height, and I'm going to label the base with a B. The area formula for a triangle is going to be A equals 1/2 B times H, which stands for area is equal to 1/2 base times height. Back to the first column, name of shape, I'm going to write down trapezoid for our 4th row. Underneath picture of shape and directly to the right of where I wrote the word trapezoid, I'm going to draw a trapezoid. I'm going to draw a dashed vertical line segment coming down from one of the top corners of my trapezoid down that's perpendicular to the base. I'm going to label that with an H, and I'm going to label the 2 parallel sides, I'm going to label with a lowercase b, the shorter side, and an uppercase b, the longer side. The area formula for a trapezoid is A equals 1/2 times H times the quantity little b plus big B, or lowercase b plus uppercase b. That's going to stand for area is equal to 1/2 times height times the smaller base plus the bigger base. Example 1. Find the area of each shape. For A, we have a rectangle where the width is equal to 2 centimeters and the length is equal to 6 centimeters. Area is equal to length times width, so area is going to be equal to 6 centimeters times 2 centimeters. So area is going to be equal to 12 centimeters squared, or square centimeters. I'm going to go ahead and box that in. For B, we have a triangle where the height is equal to 8 inches and the base is equal to 12 inches. The area formula for a triangle is A is equal to 1/2 times B times H. So that's going to be area is equal to 1/2 times 8 inches times 12 inches. And so the area is going to be equal to, I'm going to write 8/2 times 12 inches squared. So that's going to be equal to 4 times 12 inches squared. So the area of this triangle is going to be 48 inches squared. I'm going to box that in. For C, we have a trapezoid. In this trapezoid, the height of the trapezoid is 7 feet. Little b is going to be equal to 8 feet, and big B, or uppercase B, is going to be equal to 10 feet. I've gone ahead and drawn a little square at the base where the base is perpendicular to the height to show that it is a 90-degree angle there, so it is indeed perpendicular. I'm writing down the formula for the area of a trapezoid, which is A is equal to 1/2 times H times the quantity lowercase b plus uppercase b, and I've labeled the lowercase b, which is equal to 8 feet in the figure, and I also labeled the uppercase b, which is equal to 10 feet in the figure, and I labeled my 7 feet equal to h, the height. So substituting into the formula, we're going to get A equals 1/2 times 7 feet times the quantity 8 feet plus 10 feet. I'm going to add the 8 feet plus the 10 feet first. So that's going to give me that A is equal to 1/2 times 7 feet times 18 feet. So our next line here is going to say A is equal to 18 halves times 7 feet squared. And so A equals 9 times 7 feet squared, and that will give us the area equal to 63 feet squared. I'm going to box that in, and that's going to be our answer for that problem. Example 2. Find the area of the region enclosed by the line y equals negative 2x plus 8. The y-axis and the x-axis. Let's start off by drawing a picture. I'm going to draw a coordinate plane. So I'm going to draw a vertical y-axis and a horizontal x-axis. I am going to label the y-axis from 0 to 8 with tick marks, and they're going to be from 0 to 8 by a scale of 1. I'm going to go ahead and draw a point at 0, 8, and I'm going to label it with the corresponding ordered pair 0, 8. I'm going to draw one tick mark on the x-axis from 0 to 1 by a scale of 1, and therefore I will have one more point that is on this line because this line has a slope of -2. So from my y-intercept, I'm going to go down 2 units and then 1 unit to the right, which will land me at the ordered pair 1, 6. I want the point that's going to give me the x-intercept. So I have drawn my line, extended my line all the way to the very end of the coordinate plane. I have drawn a point where the line is crossing the x-axis, and I drew a question mark next to that point because that's the value, that x-coordinate that I really need to know here in order to find the base of this triangle. I have taken my line, which is y equals -2x plus 8. I set it equal to 0, replacing the y with a 0 and solving for x to get my x-intercept. So I have subtracted 8 from both sides. I have divided both sides by -2, and I have gotten x equals 4. Therefore, the x-intercept is going to be at 4, 0. Now, I can see the shape of the triangle here. I'm going to go ahead and shade in that region of the area that is enclosed by the line y equals -2x plus 8, the y-axis and the x-axis. So I'm going to go ahead and draw some diagonal lines just to represent my shading within that region. I've written in the values for the x values on the tick marks that I drew in from 0 to 4 by a scale of 1. I've labeled the height as h equal to 8, the base b equal to 4. I wrote down the formula a equals 1/2 times b times h. So that means the area is going to be equal to 1/2 times, I'm going to write 4 over 1 for the base times 8 over 1 for the height. The area will be equal to 32 divided by 2, which will give me 16. Therefore, the area of this region is going to be equal to 16 And we could represent that as 16 units squared or 16 square units. I'm going to write down 16 units squared, and I'm going to box that in. Example 3. Find the area of the region enclosed by the line y equals 1/2 x plus 1, the line x equal to 2, the line x equals 12, and the x-axis. We're going to begin by drawing a picture to represent this. I'm going to draw a coordinate plane. So I'm going to draw the vertical y-axis, the horizontal x-axis. I'm going to go ahead and start graphing my line y equals 1/2 x plus 1. So I've started at the y-intercept at 0, 1. I've gone up 1 unit and to the right 2 units to put another ordered pair on the coordinate plane. The second ordered pair is at 2, 2. I've drawn a line going through the 2 points. I've extended my line to the ends of the coordinate plane, and I've drawn arrows on the ends of the line. I've also drawn a vertical line at x equal to 2, and I've labeled that line at the bottom of the line with the equation x equal to 2. I'm erasing the line y equals 1/2 x plus 1, and I'm redrawing it so that I've extended it even farther, and I've also extended my x-axis to the right even farther because I'm not going to have enough space here to actually represent that shaded region here. Now I have gone ahead and labeled the x-axis from 0 to 12 with tick marks by a scale of 1. I actually wrote in the value for that 12th tick mark with a 12, and I drew a vertical line going through x equal to 12. I've labeled that line with the equation at the bottom of the line, x equal to 12. I've drawn a point at the point of intersection between the line x equals 12 and y equals 1/2 x plus 1. And I went ahead and I labeled the parallel lines of my trapezoid that is created by this region with lowercase b at x equal to 2 and uppercase b at x equal to 12. And then my height is going to be represented with the length, or the measurement of the length between x equal to 2 and x equal to 12 on the x-axis. So that's going to be 12 minus 2, which is equal to 10. I know the lowercase b is equal to 2 units because that measurement is from 0 to 2 if I measure using the y values. I do not know the measurement of my capital B, my uppercase B. So I do have the point of intersection here because I plotted the point, and I have the ordered pair 12, question mark, but I don't know the y value of that point. So I'm going to go ahead and figure it out by plugging in 12 into the equation of y equals 1/2 x plus 1. So y equals 1/2 times 12 over 1 plus 1. Y is equal to 12 divided by 2 plus 1. Y is equal to 6 plus 1. So y equals 7. So my uppercase B is equal to 7. So I gone ahead and I labeled my ordered pair for that point 12, 7. Therefore, my formula for my equation that I'm using here, since it is a trapezoid, is going to be a equals 1/2 h times the quantity lowercase b plus uppercase b. And when I substitute in for these values in the formula, I'm going to get a equals 1/2 times, I'm going to write 10 over 1 for the height, times the quantity 2 plus 7 inside parentheses. Next line is going to say a equals 10 divided by 2 times 9. And a is going to be equal to 5 times 9, which is equal to 45. So that area is going to represent, the area of this region is going to be equal to 45 units squared. I'm going to box that answer in.